K Pure Math Unit 2, we're looking at the May 2023 exam. Let's get right into it. So question 1, it's a complex number question. A point Z moves in the complex plane such that, and we have Z minus 2 minus 3i is equal to 4 minus 2i minus Z. Sketch the locus of Z on the Argand diagram. So when it's the complex number is written in this form, so this is form, this is Z minus A modulus of Z minus B. The locus is really, so locus, it's in this form, the locus is the perpendicular bisector of the line that joins A to B. So in this case, I can rewrite this. Let me just rewrite this. A would be, let me just rewrite this. So this is Z. I can factor minus 1 there. So I'll end up with 2 plus 3i. So this would be like the A, the point 2, 3. And the other side, this is, well, it's already, okay, 4 minus 2i. So, well, in writing this, what I can do is times inside by minus 1. So we'll end up with, I'll put Z at the front to get it to look like this. So times everything inside by minus 1, I end up with Z minus, and it's like I multiply 4 minus 2i times minus 1 also. So this would be like the B. So the coordinates of A would be, so A would be the point 2, 3, and B would be the point 4 minus 2. So the locus is the perpendicular bisector of the line joining 2, 3 and 4, negative 2. Let's sketch that line. So 2, 3, so this is 0, 1, 2, 3, 4, and 2, 3, so I need 1, 2, 3, so 2, 3, so A, 2 on the real axis, 3 on the imaginary axis, and B is a point 4, negative 2, so this is negative 1, negative 2, so 4, negative 2, so this will be, call this A, 4, negative 2 will be the other point, let's call it B. So we have our line joining A to B. And the locus would be the perpendicular bisector of a line joining A to B. Let's find the midpoint of AB, the midpoint, I'll call it M. And we know to get the midpoint of any line, you add the 2 x coordinates. So we add the 2 x coordinates there, that's 6. Divide by 2, that's positive 3. We add the 2 y coordinates. We get positive 1 divided by 2, that's half, or 0.5. So the midpoint would be about 3/2, it would be somewhere about there. So the locus, let me put it in a different color, would pass through the midpoint. Alright, would pass through the midpoint. And of course, this angle would be a right angle since it should be perpendicular. So the locus, it's the perpendicular bisector of AB. So it passes through the midpoint of AB and it forms a right angle with AB. So this is a locus. Alright. Part B, determine the Cartesian equation of the locus of Z. So remember, the locus of Z was the perpendicular bisector of AB. So remember AB, A was a point, let me remind you. A was 2, 3, and B was 4, -2. And we found the gradient of the line AB. So gradient of AB, we'll call this x1, y1, x2, y2. So gradient of AB, if it's the gradient, we can just y1 minus y2, that's 3 minus 2, x1 minus x2, that's 2 minus 4, so that's 5 over minus 2. Alright, and remember the midpoint of AB was, remember, at the x coordinates and divide by 2, we got 3. At the y coordinates and divide by 2, we got half. Alright, so if the gradient of AB was 5, -2, that means the gradient of the perpendicular bisector, therefore the gradient of bisector would have been, the gradient of the perpendicular bisector would have been the negative reciprocal. So the negative reciprocal of 5 over -2 is 2/5. Remember that if two lines are perpendicular, then one gradient, well, the product of the gradient should be -1, which means that one gradient is a minus reciprocal of the other. Alright, so to find the equation of the perpendicular bisector of AB, we can use y equal mx plus c. And we know this line, it passes through the midpoint. Since it's a perpendicular bisector, it passes through the midpoint, which is 3 -half, well, 3 half, and it would have a gradient, which is a negative reciprocal of AB. So the gradient would be 2/5. So we can substitute these into y equal mx plus c. Alright, we replace a y with a half. This is x, this is y. M with 2/5. X with positive 3. And we have plus c there. So we can solve for c. So half equals 6 over 5 plus c. Group the constants on the left. So half minus 6 over 5 equal to c. LCM here would be what, 10. So it's 5 minus 12 equals c. That's minus 7 over 5. So therefore, equation of the locus is y equal m, and m 2/5, right? Plus c, and c will be -7 over 5. That's one way to find the locus of the complex number. The other way would be to be, let's look back at what the problem was. Alright, the other way, let me just separate this. So I'll put R. So remember, the original problem was Z minus 2 minus 3i equal to 4 minus 2i minus z. So that was the original problem, and we can let z be equal to x plus iy. So replace z with x plus iy, so z, that's x plus iy minus 2 minus 3i equal to modulus of 4 minus 2i, and we're letting z be x plus iy, so this is minus x, so this is modulus. Alright. So this is minus z, so it's minus x plus iy. So minus all of that, so it's minus x minus iy, alright? Okay, let's group the real versus the imaginary part. So the real part here would be x minus 2. And the imaginary parts, so this x minus 2. And the imaginary part will the parts where there's an I term, there's an I in the term. So notice we have iy and minus 3i. So we factor the I for these two terms with the I, we'll have actually y minus 3. That's the imaginary part. Over here, the real component here is 4 minus x. And the imaginary part is a part where we have an I. Alright? So factor out I. Here we'll have minus 2 and minus y. Right, so for the modulus of both sides, so the formula for the modulus is the square root of the real part square, so that's x minus 2 square plus the imaginary part square, y minus 3 square. Over here, square root, the real part is 4 minus x, so 4 minus x square plus the square of the imaginary part, which is minus 2 minus y all square. So of course we can square both sides and get rid of the square root, right? So if we square both sides, that will take care of the square roots. And then we can expand the bracket here. So let's expand the bracket. So x minus 2 all square, that's x square minus 4x plus 4 plus y minus 3 all square, that's y square minus 6y plus 9 equal to, on the right hand side, 4 minus x all square, that's 16 minus 8x plus x square, and the minus 2 minus y all square, that's 4 plus 4y plus y squared. Alright? Now we can notice that we can subtract x squared from both sides. So x squared subtract from the left, x squared subtract from the right hand side. What else? We can subtract 4 from both sides. So 4 from the left hand side, 4 from the right hand side. We can subtract y squared from both sides, y squared from the left, y squared from the right. That would leave us with, on the left, we only have what now? Minus 4x minus 6y plus 9. And on the right hand side, we'll have 16 minus 8x plus 4y. Alright, continuing. Let's separate this. Continue down here. So we can group the like terms. So let's group the like terms. Alright, so I can group the, well, let me group the y's on the right hand side. So here we have 4y. For group 6y over here, negative 6y is actually positive 6y. Okay? Let me group everything else over here. So if I bring over the negative 8x, that's positive 8x. We already have a negative 4x there. See that we have positive 9. If I group with 16 over here, that's negative 16. So I group x with x's and constant with constants. 4 and 6, that's 10y. 8x take away 4x, that's 4x. 9 minus 16 That's minus 7. And then we can divide each term by 10, just a transpose for y. So we divide each term by 10. So we end up with y. This is 4 over 10. That's actually 2/5, right? So 2/5 x minus 7 over 10. And if I just turn it around, then this would give me, let me make y, put the y on the left. Let's turn it around. It will be 2/5 x. So I made an error somewhere here. 2/5 x minus 2/5 x minus 7/10. There's a difference here. Let me just check what the error is. So our error was actually here. This x is actually minus 7 over 10. So C is actually minus 7 over 10. So in both instances, both methods, we get the x, we get the same answer. Let's move on. Given that x cubed y minus 2xy squared equal cos xy, find dy by dx. So it's an implicit differentiation. So let's begin. So we'll apply the product rule to x cubed y. So differentiate x cubed. You get 3x squared. Keep the y. Plus, we're alternating now. So this time, we'll keep the x cubed and differentiate y. We actually get dy by dx. Now we're going to differentiate minus 2xy squared. Let's put a bracket there, minus 2xy squared. So differentiate the 2x, we get 2. We keep the y squared. Plus, we alternate. This time now, we keep the 2x and differentiate y squared using the chain rule. So multiply by the y power, subtract 1 from the y power. So we end up with 2y, and then we differentiate the y, we end up with dy by dx equal to, on the right hand side now, we'll differentiate the trig function, so we'll differentiate what's in the bracket. Alright, so what's in the bracket? xy, so we actually use the product rule to differentiate what's in the bracket, and differentiate cos is minus, so we'll begin with a minus. Alright, so minus, differentiate the xy, differentiate x, we'll get 1s, leave a y, plus, and we alternate, we keep the x, differentiate y, we get dy by dx times, and then differentiate cos, cos becomes sine, and what's in the bracket does not change, so it's still xy in the bracket. So all we need to do now is to just simply group the dy by dx terms and factor out dy by dx in solving for dy by dx. Alright, so let's expand these brackets. So we have 3x squared y plus x cubed dy by dx. Now we distribute minus, is that we're multiplying each term in the bracket by a minus 1. So minus 2y squared minus, and then 2x times 2y, that's actually 4xy, right? So 4xy dy by dx. Let's bring this equal sign closer, give them more space on the right hand side. So we distribute, we're going to multiply each term in the bracket now by sin xy. Well, actually, negative sin xy. So negative sin xy times the y, that's negative y sin xy, and negative sin xy times x dy by dx, that's actually negative x sin xy, and I put the dy by dx last. Negative x sine xy. I'll put the dy by dx first. Alright, so negative x dy by dx sine xy. Doesn't matter since you're multiplying, the order is not important, but put it like this. Let's group all the dy by dx terms on the left now. So we have 1 here. So here's a dy by dx term. So we have x cubed dy by dx is also another dy by dx term. We have minus 4xy dy by dx. And we have a dy by dx term here. So we're grouping on the right hand side. It will be positive, right? So it was plus x dy by dx sine xy. And then we'll put everything on the other side now. So I'll put the 2y square first. Bring the 2y square over. So that's positive 2y square when it groups on the right. And we have minus y sine xy. I mean minus, and then 3x square. Group on the other side, it's actually now negative 3x square. Alright, let's factor out dy by dx. So we factor out dy by dx. What we end up with now is x cubed from the second term, that's minus 4xy, and then x sine xy. On the right hand side, that's 2y square minus y sine xy minus 3x square. And then to get dy by dx, we divide by the bracket here. Divide both sides by the bracket here. So divide by x cubed minus 4xy plus x sine xy. Divide the other side by the same thing. X cubed minus 4xy plus x sine xy. Right, so this bracket divides into itself, leaving us with just, so dy by dx is what we have here on the right hand side. Let's move on. Part C of question 1, given that 3z squared minus pz plus 2q equal to 0 has a root 3 minus 5i, determine the values of p and q, where p and q are real numbers. So if a complex number has a root 3 minus 5i, then the other root is just the conjugate, which is just change the middle sign, 3 plus 5i. So that's the thing with complex numbers. Alright, when you're given one root, you automatically know the other root. The other root is just a conjugate of the first root that you're given. So we have a quadratic. Now we also know that for a quadratic, the sum of the roots is equal to negative b over a, and the product of the roots is c over a. Now a, what's a? A is just the coefficient of the square term. B, the coefficient of the z there, and the constant c there would be 2q. So we know the roots. Alright, so the sum of the roots, so one root is 3 minus 5i, plus the other root is a conjugate, 3 plus 5i. So if you sum these roots, the roots of the quadratic, it should be equal to negative b over a. So b is actually negative p, so negative b will be positive p. A the z-square coefficient, which is positive 3. Alright, so we add, so 3 and 3, that's 6. Negative 5i plus positive 5i would cancel to give 0, right? So we ask with 6 equal p over 3. So to solve for p, we can just cross multiply there. 1 times p is p, 3 times 6 is 18. On the other side, the product, the roots are 3 minus 5i times the other root is conjugate 3 plus 5i equals c, the constant there is 2q, and a is positive 3. So let's expand the bracket. So 3 times 3, that's 9. 3 times 5i, that's 15i. Negative 5i times 3, that's negative 15i. And that's always when you're multiplying a complex number by its conjugate. Alright, the two term always cancel. Negative 5i times positive 5i, that's negative 25i squared equal to 2q over 3. So the two term cancel. So you actually have 9 minus 25, and recall that I squared is actually negative 1. So replace I squared with negative 1. That's what it is, equal to 2q over 3. So this is actually 9 plus 25, that's 34. So 34 equal to 2q over 3. And of course you can just put the 34 over 1. Cross multiply. We end up with 2q equal 3 times 34. That's 102. Divide both sides by 2. Q is equal to 51. Let's move on. Using the Moivre's theorem, determine the square root of 1 minus I times root 3, or root 3 times I. So if I'm using the Moivre's theorem, I need to write the complex number in its polar form. So I need to write 1 minus root 3 times I, like that, in its polar form, which is r cos theta plus I sin theta. Alright, so we need to find r and we need to find theta. So we get r, so r square is equal to a square, that's 1 square, plus root 3 square, so a square plus b square. So r square is equal to 1 plus root 3 square is 3. So r square is equal to 4, which means r is equal to 2. And then I need to find theta. The theta is tan inverse b over a. So that with tan inverse negative root 3 over 1. So tan inverse root 3. And tan inverse root 3 is 60 degrees. Alright, 60 degrees. So they want the angle in the radians. So that's, well, negative 60 degrees. So that's in radians. To convert to radians, I multiply by pi over 180, right? So 16 to 180, that's 3. So I'm negative pi over 3. Alright, so let's separate this. So that's pi. So this is 1 minus root 3i equal to r. And by the way, when finding theta, so the real part is 1, imaginary part negative root 3, so negative root 3, so 1, negative root 3, so that's a point there. So the angle will be here. So of course it's a negative acute angle, right? So we use negative pi over 3. Since it's moving from the positive side of the x-axis, you're moving clockwise there. So this is the angle we're talking about. 60 degrees, so negative pi over 3. Alright? Alright, so rewriting the complex number in its polar form. So r is 2, so this is equal to 2 cos negative pi over 3 plus I sine negative pi over 3. Alright? So we are asked to find, so 1 minus 3i is equivalent to what we have on the right hand side there. It's a complex number in its polar form. So we need to find the square root of 1 minus root 3. So the square root is like, the square root is same as raising the number to a half. Alright, so let's raise both sides to a half. Alright, so this is 1 minus root 3i. Same as raising root 3, 1 minus root 3i to the power half. So root 1 minus root 3i equal to, now 2 to the half, 2 to the half, 2 to the half. So what the Marvel's theorem says, the r, you raise r to the power of half. So 2 to the half, that's same as root 2. And then you multiply r by the angle there, right? N by the angle there. So the Marvel's theorem states that you would raise r to the n, you raise r to the n cos n theta, where n is a power, plus I sine n theta. That's what the Marvel's theorem states. So we raise r to the n is half, so r to the half, root 2, and then n times theta, n is half, so half times theta. That will give us cos minus pi over 6. Let's bracket that. Plus I sine half times pi over 3 is minus pi over 6. Alright, so this question I could leave the answer like that in radians, but let me just expand it. So root 1 minus root 3i is equal to root 2 in the bracket. Cos negative pi over 6 is the same thing as cos pi over 6. Alright, cos pi over 6 is what, 30, so cos 30, that's actually root 3 over 2 plus, alright, sine negative 30 is actually a negative value. Sine negative, that would be negative half, right? So negative half I. Since sine 30 is a half, so sine negative 30 is negative a half. Alright, and of course, yeah, so that's the best we can do with it. So common denominator there of 2, and in the bracket we have root 3 minus I. So if we expand each term in the numerator by root 2, this is root 2 times root 3, root 2 times I. I want to know root 2 times root 3, that's root 6. So this is root 6 minus root 2 times I over 2. I guess that's the best we can do with it in terms of simplifying. Question 2. Use integration by parts to evaluate the integral of sec square x cos square x. So you have a couple of formulas we could use. I prefer to use this formula I'm using, the integral of u times v dx. So I'm using a formula where we integrate one of them. So let me, which formula should I, so I could v, let me choose, so v times the integral of u, that's the formula I'm using, integral of u dx minus the integral, and of course this integral of u, we repeat it here, and the other term will differentiate it, so v prime. Okay, that's the formula I'm using. Alright, so integral of sec square x cosec square x dx. So I'm calling my u sec square, since I know the integral of a sec square is tan. So I'm calling my v cosec square. Alright, so following this formula, so the integral of sec square, so I'm going to put v, so v is cosec square, so I put cosec square. Following the formula here, I put the cosec square x, and the integral of u is sec square, the integral of sec square is tan. Should know that from memory. Integral of sec square is tan x. Right? And then minus, do I have space? Minus, I'll put integral, and this integral here, the integral of u, which what we have here was cosec square. We repeat it, so cosec square, repeat cosec square x there, and then we differentiate v. So my v was cosec square, derivative of v, so v prime, let me just put v prime here, so v prime, that's the integral of cosec, that's the derivative of cosec square. I'm using the chain rule to differentiate it, so it's 2 times cosec square x, and then when cosec square x is differentiated, we get, sorry, so no, that's not it. So I'm using v to be cosec square x. So v is cosec x square. So I'm using the chain rule, alright, to differentiate that. So it's 2 times that, so it's 2 times cosec x, and then I differentiate what's in the bracket. Differentiate cosec x, I get minus cosec times cot. So I get minus cosec times cot x. Alright? So the derivative of cosec is minus cosec times cot. So what I have here now is v prime. So integral of u, which is cosec square. I'm making an error here. The integral of v, the integral of u, sorry, I made an error here. The integral of u, I repeat it here, since my u was sec square, integral of u is tan, actually. Integral of u, which I have here, this, repeat it both sides, so integral of u, here is u, it's integral, it's tan, which I have here. Alright, so I repeat it, so this is actually tan. And then v prime is cosec square differentiated. Alright, which is cosec square differentiated, which is negative 2 cosec square times cot. Negative 2 cosec square x times cot x dx. Alright, so continuing on the right hand side there, so of course I have my cosec square x tan x, and then I have the double negative, so I have negative negative, so it's actually plus 2, and I'm going to put the 2 outside the bracket since it's a constant. And what I have here now is, now tan is the reciprocal of cot, so the tan times the cot will give me 1, so that cancels. So all I have here is positive cosec square x remaining here. Alright, so, and then continuing, I'll end up with again cos x square x times tan x cos x square x times tan x plus 2 times the integral of cos x square. And we should know the integral of cos x square is actually minus cot, so this is actually minus cot. Minus 2 cot x. So integral of cos x square is cot, so minus 2 cot x. So it's important to know this integral from memory, sine, cosine, and their reciprocal. Sec, cosec, cot. And of course, we have no limit, so we put a plus c there. And that's that. Let's move on. Part B, evaluate the integral of 3x over x squared minus 4x plus 5 between the limits 5 and 2. So this seems like we'll have to use integration using this by the substitution method. So we could complete the square in the denominator, so rewriting this. So this is 5 and 2. So this is 3x over, so obviously logs won't work. So this is 3x over, complete the square here, this x, let me just complete the square here, rough work. So it's x squared minus 4x plus 5. Complete the square, that's x minus 2 all square. Minus the square of the 2 here, so that's minus 4 plus the 5. So it's actually x minus 2 all square, negative 4 plus 5. That's 1. So we can rewrite this denominator as x minus 2 all square plus 1. And of course we can use u substitution. So we can let u be equal to whatever is in the bracket. So we can let u be equal to x minus 2, differentiate du by dx, differentiate the right hand side, we get 1, and if we cross multiply, du equal to dx, and of course we let u equal to x minus 2, so really, so if you transpose from here, bring over the 2, negative 2, u plus 2 is equal to x. So we can transpose here, so let's, and by the way, also need to change the limits, by the way, since we're doing u substitution. So the dx is equal to du, so we can replace the dx with du. Alright, 3x, now x is u plus 2, so 3x is 3 times u plus 2. So 3x, that's 3 times x, x is u plus 2, so 3 times u plus 2, that's 3u plus 6, and the denominator, we had let u equal x minus 2, so this is u squared plus 1. The limits now, when x is 2, u equal to 2 minus 2, which is 0, and when x is 5, u equal to 5 minus 2, which is 3. So we can adjust our limits like that. And we can, of course, next we can break up the terms here, so we can rewrite this as integral between 3 and 0. Break it up, so this is 3u over u squared plus 1 du plus the integral of 6 over u squared plus 1 du. And of course we're using the same limits, 3 and 0. Alright, so integrate this. We can simply log the denominator, so ln u squared plus 1. Ln u squared plus 1. Now if we try to differentiate this with respect to u, we'll get 2u at the top, but we actually want 3u. So to get rid of the 2 that would have here, you can divide by 2 and multiply by 3. Integrating here, since it's the same limit, we can just integrate here. Integral of 1 over u square plus 1. So you can look at the 6, look at it like that. You can put the 6 here. This is 6 times, and this is tan inverse. Right, so this is tan inverse u. And both of them have the same limit, so of course we can just use one bracket there. Same limit 3 and 0. Alright, so we formulate 2 brackets. In the one we replace the u with 3, in the other replace the u with 0. In the first bracket replace u with the top number, so that's 3 over 2 log u is 3, so 3 squared 9, 9 and 1 10, so log 10 plus 6 tan inverse 3 minus, in the other bracket replace u with 0, so that's 3 over 2 ln 0 squared plus 1, so that's ln 1 plus 6 tan inverse 0. Alright, now ln 1 is 0, tan inverse 0 is 0, so all we're left with is 3 over 2 ln 10 plus 6 tan inverse 3. Let's move on. Part C, determine the integral of x plus 1 over x cubed minus 9x. Let's try and rewrite the denominator. So logging won't work. Right, so integral, this is x plus 1. Now the denominator, x cubed minus 9x. X cubed minus 9x. Let's just try to fix that up. X cubed minus 9x. So we can factor out x. We have x into x squared minus 9, and x squared minus 9 a difference of squares, so that's x minus 3 x plus 3. So this factorize, the denominator factorizes x into x minus 3 into x plus 3 dx. Alright, so first we write the denominator and then we can write it in partial fractions. So let's rewrite this as integral of a over x plus b over x minus 3 plus c over x plus 3. So we're going to break it up into partial fractions. Let's proceed now to find the values of a, b, and c. Let me just do it over here. So let me just make some space. So what we have is x plus 1 over x cubed minus 9x. We're going to put it in partial fractions now. So a over x, b over x minus 3, c over x plus 3. Alright. So what I'll be doing, I'll be multiplying both sides. I'm going to times each term on both sides, each term on both sides by this denominator here. Alright, x bracket x minus 3 times x plus 3. Alright, so if I times it to the left hand side, the denominator will just cancel because this is same as this, right? So times it to the term on the left hand side, I'll be just left with x plus 1. Times it by the term with the a, the x will cancel. So I'll be just left with a over x minus 3, x plus 2. So actually a times x minus 3, x plus 3, sorry. So I'm left with a times x minus 3 times x, since the x will cancel. So x minus 3, x plus 3, that will be just x squared minus 9. Alright? Plus, if I times it by the b term, the x minus 3 will cancel. So I will be left with x and x plus 3. And if I times it by the c term, the x plus 3 will cancel. So I'm left with cx times x minus 3. Alright? So we can let x be different values now. So we can let x be, if we let x be 0 first, let's do so. Let x be 0. If I let x be 0, the left hand side would be 1. X is 0. This would be the bx, b times x, that's 0, so that's about 0. C times 0, 0. So all we're left with is a times 0 square minus 9. So the bracket will come to negative 9. So a will be negative 1 equal to negative 9a. And if I divide both sides by negative 9, a will be negative 1 over 9, right? So a, so here, let me just rewrite this. So the a is negative 1 over 9. So a, this will be negative a, negative 1a. A is negative 1 over 9. So the negative 1 over 9x, that would what we have there, alright? Let's find the value of b, or whatever. But we can also let x be equal to what? We can let x be equal to, positive 3. Let's x be equal to positive 3. So we can let x be equal to positive 3. If we let x be equal to positive 3, the left hand side, 3 plus 1, that's 4. X is 3, then this would become 0, because 3 squared is 9, 9 take away 9, 0. The c term, 3 take away 3, that's 0. So I will be left with is a b term. If x is 3, this will be, if x is, this will be 3 times 3 plus 3. Now 3 plus 3 is 6 in the bracket here. So what we have is 3 times 6, which is 18. Alright, so this would be 18b. So having for b, I divide both sides by 18. So b equal to 4 over 18, which is 2 9s. Alright, so b is 2 over 9. So this would be 2 over 9, right? Replace, so this would be, b is 2 over 9, so it would be 2 over 9 x minus 3. And then to get c, what can we let x be equal to now? To get c, we can let x be equal to negative 3. Let's let x be negative 3 now. Let's create some space. Let x be negative 3. If x is negative 3, what we have here is negative 3 plus 1. Negative 3 plus 1, that's negative 2. If x is negative 3, this term will cancel, because negative 3 plus 3 is 0. If x is negative 3, what you actually have, negative 3 squared, 9, take away 9, that's also would be 0. So just a final term, if x is negative 3, what you have here is negative 3 times c, that's negative 3c. In the bracket, you'll have minus 3, that's minus 6 actually. So what you'll end up with is minus 2 equal to minus 3c times minus 6c, that's positive 18c. And if I divide both sides by 18, alright, so c will be negative 1/9. So negative 1/9, c will be negative 1/9, alright? So c, so this would be negative 1/9. So this is actually negative 1/9 over x plus 3 dx. And we know the integral of 1 over x is log x. So this actually integrate this, that will be negative 1 over 9 log x. This would be 2 over 9 log x minus 3 minus 1 over 9 log x plus 3. And we don't have no limit, so we put a plus constant there for to compensate for the lack of limits there.